So we've talked a little bit about sine, cosine, and tangent, and how the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And now we're going to learn how to use sine, cosine, and tangent to figure out the lengths of the sides of a triangle. Now, before we do that, let's take a look at the triangle over here. You notice that this is a right triangle, and one of the other angles is 40 degrees. Now, we have no idea how big this triangle is because we don't know any of the sides, and the fact that the angle is 40 degrees doesn't tell us how big the triangle is. But what we can figure out based on the angle is the ratio of the opposite divided by the hypotenuse, or the ratio of the adjacent divided by the hypotenuse, or the ratio of the opposite divided by adjacent. Because when you have a 40-degree angle, or any angle, the sine, cosine, and tangent of an angle are always the same for any given angle, regardless of how big the triangle is. So for example, let's say I want to know the ratio of the opposite side of this triangle. The opposite side would be the one on the left, divided by the hypotenuse. So all I need to know is the sine of 40 degrees. And the sine of 40 degrees is a set number. To find that number, you just type in the calculator sine of 40, and you get 0.6428. That means the sine of a 40-degree angle is 0.6428, which means that the ratio of the opposite side and the hypotenuse, if you took the length of the opposite side divided by the length of the hypotenuse, you get 0.6428. Again, we don't know how long either of those two sides are, but we do know that's the ratio of the two sides. And the same is true with the cosine. If I want to know the ratio of the adjacent to the hypotenuse, I would type in cosine of 40, and I would get 0.7660. That's the ratio of the adjacent to the hypotenuse. And if I want to know the ratio of the opposite to the adjacent, I would do tangent of 40, which equals 0.8391. So the point is that once you know the angle in a right triangle, you may not necessarily be able to calculate the sides, but you can calculate the ratio of the two sides. And this is especially helpful if you do know one of the sides. You can use that ratio to then figure out how big the other sides are. Because if you know the ratio and you know one of the sides, you can figure out the other sides. Let's look at a couple examples of how to do that. So over here we have a triangle. We know this angle is 72 degrees. This is the right angle. The hypotenuse is 17, and this other side is x, and we want to figure out how big x is. We want to know the length of this side on the bottom. So the first thing we have to do is we want to figure out, are we going to be using sine, cosine, or tangent? And the way to figure that out is you have to look at the sides that you have, either the side that you know and the side that you're trying to figure out. Are they the opposite, the adjacent, or the hypotenuse? So in this case, clearly the hypotenuse is 17, and the x is the opposite side. So the opposite equals x. Well, if we have the hypotenuse and the opposite, so do we want to use sine, cosine, or tangent? Well, the sine is the one that is opposite divided by hypotenuse, so we're going to want to use sine. So the way to set it up is we write it as follows. The sine of 72 degrees equals x over 17. Because again, sine is opposite divided by hypotenuse. So the sine of the angle, the sine of 72, equals the opposite, which is x, over the hypotenuse, which is 17. Note how the angle is always what you're going to put next to the sine or the cosine or the tangent. You're not going to take the sine of one of the sides. You're taking the sine of the angle equals the opposite over the hypotenuse. Now to calculate this, the first thing we're going to do is figure out what's the sine of 72. That we'll do on a calculator, and we'll get 0.9511. Sine of 72 equals 0.9511, and that will equal x over 17. So you have 0.9511 equals x over 17. Now just to solve for x, the last step is, well, we want to get x by itself. So x divided by 17, we have to multiply both sides by 17. That will give us 16.2 equals x. 0.9511 times 17 equals 16.2 approximately. So that means our final answer is x equals 16.2. And it's good to check to make sure that makes sense. Well, if the hypotenuse is 17, we know the hypotenuse has to be longer than the other side, so x has to be less than 17. But looking at the picture, it doesn't look like it's that much shorter, and it's pretty close. X, in this case, equals about 16.2. Notice how when I did the sine and cosine, I rounded to about 4 decimals, but in the final answer, you can just round to 1 decimal, and it comes out to be 16.2. Let's look at another example over here. Over here, we have a 46-degree angle. One side is 3.5, and the other side is x. So again, the first step is to figure out, do we want to use sine, cosine, or tangent? Well, it looks like x is the opposite side, and 3.5 is the adjacent side. So that means we have opposite and adjacent, which means we're going to use tangent. Tangent is opposite over adjacent. So setting up the equation, we have tangent of 46 equals x over 3.5. Again, tangent of the angle equals the opposite over the adjacent. Tangent of 46 equals 1.0355. So we have 1.0355 equals x over 3.5. The final step is to multiply both sides by 3.5, and that gives us x equals 3.6. So our final answer is going to be x equals 3.6. And again, looking at the diagram, it makes sense. It looks like the two sides are pretty close to each other. So the answer is going to be x equals 3.6. So again, to review the steps, the first thing you want to do is figure out, do you want to use sine, cosine, or tangent? Look at the two sides that you're dealing with. One of them you already know, one of them you're trying to figure out. Based on which two sides they are, determine whether you want to use sine, cosine, or tangent. Then set up the equation, make sure to get the right thing on top and the right thing on bottom. In these problems, the x always came out on top. Obviously, the x could come out on bottom, but for these problems, the x always came out on top. And once you do that, you plug in sine, cosine, or tangent of whatever angle you have, and then you just solve the equation, and that will allow you to figure out the length of the missing side.